to talk about Math 121. This is the class, and we're going to start talking about, first of all, about permutations and combinations. Now, I was able to lecture on permutations and combinations to some of my students, but not everybody. And we had spring break, and it was off all week, and now uh, they they won't have. I was told none of the college employees are supposed to be at any of the campuses. I got an email from the president today. So this is an epidemic that's going on right now. That anyway, it's um, nobody's supposed to be. None of the instructors or professors are supposed to be at the college. You know, so anyway, all classes will be online for the rest of the semester, and the graduation is canceled. Okay, in May. So I know some of you are disappointed about that, but that's just the way it is. That can't be helped. Okay, now first of all, we're going to talk about permutations and combinations, and then after that, I'll start reviewing the material for the test number 2. And I'll probably make another video on everything that we've covered since the last test. Okay, so now the formula for a permutation, NPR, is n factorial over n minus r factorial. So in other words, if you have 6 things and you want to pick 2, okay, or a permutation is an ordered arrangement of objects. This is n minus r. It'll be the largest number factorial over the difference of the 2, 6 minus 2 factorial. And 6 factorial is 6 times 5 times 4 times 3 times 2 times 1 over 4 factorial, which is 4 times 3 times 2 times 1. And this 4 times 3 times 2 times 1 cancels. And so that leaves you with 6 times 5, which is 30. Okay, so 6p2 is 30. So if you have 6 objects and you want to pick 2 of them, where there's an ordered arrangement, okay, ordered, it means it's very important which ones you pick first, what order you choose those arrangements in. So there's 30 different ways to pick 2 items from 6 if there is an arrangement of order. Okay, now if there's not an arrangement of order, if order doesn't matter, okay, let me see here. Okay, now I had to erase that picture. Okay, it's been a little while since I've used this computer, this program to do this, so I kind of haven't used it for a while, so I kind of had to refresh my memory on how to do that. Now, a combination formula, NCR, NCR is n factorial over r factorial times n minus r factorial. So if you have 4 things and you want to pick 3, by this formula, that's 4 factorial over 3 factorial times 4 minus 3 factorial. And 4 factorial is 4 times 3 times 2 times 1 over 3 times 2 times 1. And then 4 minus 3 is 1, which is 1 factorial, and 1 factorial is 1. So the 3 times 2 times 1 cancels, and that leaves you with 4. Okay, now this is a wedding reception problem. Add a reception line okay, this is line, the word line. The bride, the bride, the groom, the best man, the maid of honor, maid of honor, four ushers, and four bridesmaids. Okay, four bridesmaids. Okay, must line up to receive guests. Okay, A. If these individuals can line up in any order can line up in any order, how many arrangements are possible. Okay, I'll rewrite these notes and put them on Blackboard too, because I'm writing the best I can, but I don't have the best pen, and this is a touchscreen monitor, so this is the best I can do. Okay, there's four bridesmaids, four ushers, four and four is eight, the maid of honor and the best man, that's 10, and then the bride and groom makes 12. So that's 12 people, okay, and order doesn't matter, in any order. So if order doesn't matter, that would be 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 which is 479,001,600. Okay, 479,001,600. Okay, part B. If the groom must be last in line, and the bride next to the groom and the other people can line up in any order how many arrangements are possible. Okay, now the bride and groom are standing next to each other, so we'll just eliminate them. But the other people can arrange in any order they want to. So if you take the bride and groom out, because they're going to be standing next to each other, then the other people can arrange in any order they want to. So that's just going to be 10 people arranged in any possible way. So it'll be just 10 factorial, which is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And 10 factorial is 3,628,800. Now in part C, if the groom is to be last in line, and the bride is next to the groom, and males and females are to alternate, how many arrangements are possible? Okay, there's okay, you've got a best man, a maid of honor, four ushers, and four bridesmaids. So that's really five men and five women, right? Uh, so that would be 5 factorial, which is 5 times 4 times 3 times 2 times 1, which is 120, times 5 factorial. So it will be 120 times 120, which is 14,400. Okay, you assume the best man and the maid of honor, they don't have to be side by side. Now, General Mills is testing 4 oat cereals, 5 wheat cereals, and 2 rice cereals. If it plans to market 3 oat cereals, 2 wheat cereals, and 2 rice cereals, how many combinations are possible? Okay, now you have 4 oat cereals, but you have to pick 3. So this is the oat. There'll be four to choose from. You're picking 3. And then the wheat cereals, you have 5 of them to choose from, but you're only choosing 2. And then the rice cereals, you have 6 of them, but you have to pick 2. Okay, and then you multiply those together. Okay, by the combination formula, the combination formula is n factorial over r factorial times n minus r factorial. So that's the top, the largest number factorial over the bottom number factorial times 4 minus 3 factorial, which is, this is an equal sign, 4 times 3 times 2 times 1 over 4 times 3 times 2 times 1, and this is 1. The 3 times 2 times 1's cancel, and that leaves you with a 4. So C of 4, 3 is 4. Now about 5C2. That is 5 factorial over 2 factorial times 5 minus 2 factorial. And so that's 5 times 4 times 3 times 2 times 1 over 2 times 1. And this is 3 times 2 times 1. So 5 times 4 is 20. 20 divided by 2 is 10. So you have 4, 3. C of 4, 3 is 4. C of 5, 2 is 10. Now we have to compute C of 6, 2. Which is 6 times 5 times 4 times 3 times 2 times 1. And 4 factorial is 4 times 3 times 2 times 1. And this is 2 times 1, which is 30 over 2, which is 15. So now we have C 4C3 times C52 times C of 6, 2, which is 15 times 10 times 15. And you multiply those together and you get 600. So there's 600 different ways General Mills can market those cereals. Now, a license plate is to consist of 3 digits followed by 2 uppercase letters. Determine the number of license plates if A, repetition of numbers and letters is permitted, okay, so you've got 3 digits followed by 2 uppercase letters. Okay, these are your digits, and here's your letters. Okay, so those 10 digits, and the repetition is permitted, says 10 times 10 times 10, and it's 26 letters, so you multiply those together, okay? And that's 10 times 10 times 20, 10 times 10 times 10 times 26 times 26, which is 676,000 different ways. Okay, part B. repetition of numbers and letters is not permitted. Okay, now you've got 3 digits followed by 2 letters. Okay, you have 10 digits to choose from, and if you pick one of those 10 digits, you have 9 left, then you have 8 left, and then 26 letters, and if you picked one of the 26, that leaves you 25. So it's 10 times 9 times 8 times 26 times 25, which is 468,000. 468,000 different ways. The first and second digits must be odd, and repetition is not permitted. Okay, you have 3 digits followed by 2 letters. Okay, the first and second digits must be odd. So you have how many odd digits? 1, 3, 5, 7, 9. 1, 3, 5, 7, 9. 5 odd digits. And if you pick one of those odd digits, you have 4 left. And you've already used 2 of those digits, so you have 8 left of the other digits. And then you have 26 letters. If you use one of those letters, you have 25. 5 times 4 times 8 times 26 times 25 is 104,000. Okay, the first digit can't be 0. And repetition is not permitted. Okay, you have 10 digits, so the first digit can't be 0, so you have 9 to choose from, and you use one of those digits, so you still have 9 for the second digit, and then 8 for the next one, and then 26 letters and 25 for the next one. So 9 times 9 times 8 times 26 times 25 is 421,200 different ways. Okay, now the Johnsons just moved into their new home. Okay, they are selecting furniture for their living room. Okay, living room. They are considering five different sofas two different chairs and six different tables. They plan to select one item from each category. Determine the number of different ways they can select the furniture. Okay, now there's five different sofas. Now they can only select one sofa. They're going to select one from each category, one sofa, but they've got five to choose from. So it's 5 times 4 times 3 times 2 times 1, which is 120. And a chair, they select, they have two chairs to select from, so it's two different chairs, two different ways. And a table is, there are six different tables. 6 times 5 times 4 times 3 times 2 times 1, which is 720. So it's the number of ways you can select a sofa times the number of ways you can select a chair times the number of ways you can select a table. So it's 120 times 2 times 720. 120 times 2 times 720. And you get 172,800 different ways. Okay, now do want to say that a permutation is an ordered arrangement of objects. A combination is an arrangement of objects with no regard to order. So that's one difference, the difference between a permutation and a combination. Okay, now on your computer, if you go on Blackboard, there are videos for you to watch on there. Okay, if you go to the on there, I could show you where to go to find where there's videos that another instructor made, and those videos are on Blackboard. Okay, and some of them are done. I've put on there from YouTube, and some of them are done by Lisa Red Miles. Okay, let me see if I can go on my computer and I'll try to show you where they're at. I hope you could see this well enough. I had to go get my computer. Okay, now this is the computer screen. See, it says Math 121, 121A, and on the right hand side, over here, on this side over here, you'll see different links. Okay, and you should go to learning modules, the course material. And then you arrow down and you see Math 121 content. There's videos. There's a YouTube video that I put on there, how to tell permutations from combinations. And then click module 3, probability and odds. And then you'll see different videos. It says view video M3 Math 121 lesson 1. View video M3 probability lesson 2, lesson 3, and lesson 4. Okay, those are different videos by another instructor that used to teach here at the college. But anyway, they're pretty good videos, and I'll suggest you watch them. And also, what I just typed on here, okay, you can go to those links. They're at the very bottom. It says Module 3 videos. They're in brown. Lesson 1, MV. Lesson 2, MV. And it'll be easy to get to. I just thought I'd point that out to you. But what I just put on here, the problems, I'm going to try to put them on Blackboard too. So in case you couldn't read my writing. Okay. I'll suggest you go home and study those, and then I'll make up a worksheet, and then after this, I'll try to make up a set of problems for you to study, to review for your test, which I plan to give week after next. Okay? So, and if you have any questions whatsoever, please let me know. Email me. My email address is verna.phillips@southernwv.edu, and I'll send every student in all my classes an email. You should have gotten it last night. Okay? And also, I plan to put some topics in the discussion board. Under learning materials, you'll see a link that says discussions. You can go on there, and if you have any questions about the videos or anything like that, you can post things on there. Okay? Topics, and I can respond, or through the emails. But I plan to do that too on the discussion board. Okay? And also, I've been getting every student in the E classes 2 points if you attend the E classes. So, of course, you can't come to the labs right now or anything. So there won't be any attendance. It's all online for the rest of the semester. So I was told yesterday at a meeting that if you went on Blackboard each single day and you're on there a certain amount of time, now, of course, you can't just go on there for 2 minutes and get off and get 2 points. But you have to be on there a certain amount of time every 2 times a week, and you'll get your 2 points that way for the rest of the semester. And I'll keep track of who does Blackboard every week from now until the end of the semester. And if you have any questions, just let me know and email me. It, just get in touch with me, okay? And also, the test will be online, and there will be a statement at the beginning of the test saying that you won't use your books, you won't use your notes, and you will not have anybody help you with the test. And it'll be you personally who takes the test. Okay. Anyway, I was told that at a meeting yesterday to put that on the test. Okay. See you all later. I'm gonna stop the recording.